I just want to echo what Mr. Dahl said. It's a really sad time, certainly something we've never experienced before, and we're really sad that we won't be able to see you guys again, but we hope that you're able to learn from this experience and know that we still want to provide the best instruction possible for you guys. We also want you to know that if there are certain things going on at home preventing you from getting the instruction done, just please let us know. At least contact us. Let us know you're doing okay. We miss you and we want to hear from you. So we're going to continue on with target 2B, which is identifying the domain and range of a relation and understanding its restrictions. So before we go on, we need to make sure we understand certain vocab, which is relating to solving linear equations. And the first is called a relation. A relation is a set of ordered pairs which could be a finite or infinite number. So I know we know what infinite means, right? Never ending, going on forever. But what does finite mean? Well, finite is the opposite of infinite, right? We see the word finite actually in infinite. So infinite is never ending. Finite means that it does stop. So it's a set number, it stops. Okay? So a relation is a finite, so a set of ordered pairs, a set number, maybe 5 ordered pairs, or it could be an infinite number of ordered pairs, a number of ordered pairs that we can't even count. The domain are the input or the x values from a relation. And the range are the output or the y values from a relation. And when we list the domain and the range, we don't want to list any repeats when we list them. So we're going to be looking at a relation, a set of ordered pairs, and we're going to be listing the domain and the range. So let's take a look at an example. So again, this is a finite relation. It's a set number of ordered pairs. So how many ordered pairs are in the relation? Well, we have 1, 2, 3, 4, 5, 6, 7. We have 7 ordered pairs in this relation. Okay, what is the domain? Well, let's recall, what are the domain values? The domain are the x values. So I'm going to underline all of the x values in these ordered pairs. So our x value is the first number in an ordered pair. So I have 4, 6, 8, 9, 6, 11, and 0. So I want to list the x values, but I'm going to list them in order, and I'm not going to list any numbers that repeat more than once. So my smallest value is 0, and then I have 4, and then we have 6, which we actually have twice, so I'm only going to list it once. Then we have 8, 9, and 11. Okay, those are our domain values or our x values. Our y values are the range. So our y values are the second number located in an ordered pair. And again, I'm going to list those from least to greatest, and I'm not going to include any numbers that repeat. So my smallest y value is -10. Then we have -3. After that, looks like we have 2. And then we have 3. We have 2 of them, so I'm not going to list those as a repeat. And then 5 and 15. Okay, So our X values are the domain values and the Y values are the range values. Those are the first few vocab words. And now we're going to talk about how to look at those vocab words, the domain and range, when we're looking at a graph. Okay, so now we're going to move on to the next page where we're going to be looking at the domain and range when we don't have a finite set of ordered pairs. So it's easy to tell what the domain and the range are when we have a set value of ordered pairs, but what do we do if we do not? What we're going to do is that we're going to communicate the domain and range using something that you've already learned about, and that is interval notation. Interval notation, if you remember, it sort of looks like an ordered pair, but it's not. It's basically telling us what's the smallest possible value that we can have and what is the largest possible value that we can have. We previously used it when we were solving for inequalities back in Unit 2. So we're going to go through and we're going to describe the domain and range when we're given a graph. Okay, so let's take a look at this problem-solving thought process as we go through and try and identify the domain and range from a graph. So let's start with the domain. The domain is trying to tell us what's the smallest number on the x-axis that the graph includes and what's the largest number on the x-axis that the graph includes. Another way to think about this is what's the smallest number as my graph goes to the left and what's the largest number as my graph goes to the right. So let's take a look at the two ends of our graph. So as we go to the left right here, my graph is going up and to the left. But for domain, I'm just concerned about what's its direction with left to right. So as it's going to the left, I'm going to draw in a little arrow going to the left there. My graph is going to go forever to the left. So forever to the left means that we're not just stopping at negative and 10, we're including every value beyond negative 10 going to the left. So what value is that? Negative 13, negative 20, negative 300. We can go on forever. So as we're going to the left, we're including every value that exists to the left. So that means we're going to negative infinity. Okay, now let's take a look at what our graph is doing as it goes to the right. So this is the right side of my graph. It is going up and to the right. So I'm going to draw an arrow going to the right here. And I'm going to consider what's the largest value as it approaches the right side. Well, it looks like it stops at 10, but as we know, this goes forever beyond 10, 11, 12, 20, 50, 800, 8,000. It keeps going. So this is going to positive infinity. Now I'm going to look to see if I am including or excluding the smallest and largest value. So can we include infinity or do we have to exclude infinity? Well, as we know, negative infinity and positive infinity both never end. So both of those values will be excluded, which means they're going to be using parentheses. And last but not least, is there anything that we can see on the graph which would cause you to exclude a number on the x-axis? That would look like a circle in the graph, an open circle, just like we had for inequalities, which are called holes. But on this example, we don't have any, we have a continuous line from left to right. So I'm excluding my smallest value, which is negative infinity. I'm excluding my largest value, which is positive infinity. So my domain would be from negative infinity to positive infinity. Now moving on to the range. I'm going to consider the same thought process, but now I'm looking down and up. So what's the smallest number on the y-axis as I look down? So as my graph will include. So this is where my graph is going down. But this is the smallest value right here. And I want to know what is the smallest value on the y-axis. So that point is my lowest point. It doesn't go anywhere beyond that. So my smallest value is -5. Okay, now I'm going to consider what's happening with my largest value. So as I look up, well, both of these ends are going up. Now, since they're both going up, they're both going to forever upward, which includes any number that's above 10, 11, 15, 19, 8,000, 4,000. We can keep going up. So this goes to positive infinity on both ends here, which we only need to include once. So now I'm going to consider, am I including or excluding the smallest and largest value? Well, since this point right here does not have an open circle, it exists right there, I'm going to include -5. So since I'm including that value, I'm going to use a bracket. And then my largest value in my range keeps going forever upward. So I'm going to positive infinity, which I will have to exclude. Okay, now let's take a look at a couple more examples. So our first example, we're going to consider what's happening as we go to the left, to the right for our domain. So this is the left side of my graph. It's going to keep going forever up into the left. So for my domain, it's going forever to the left. If it's going forever to the left, then it's going to negative infinity. As I move to the right, it's going down and to the right, so forever to the right. So that means it's going to positive infinity. I have no breaks in the middle of the graph, so that means my domain will be from negative infinity to positive infinity. Now let's consider the range. So my range is what's happening as I go down and as I go up. Well, this is the part of my graph that's going down. So as we can tell that this graph is going forever down. So that means it's going to negative infinity. That's my lowest value. And as I work my way up, it's also going up to the top, which is going to positive infinity. So that means it's going upward forever to positive infinity. I have no breaks in the middle of the graph. So that means my smallest value for my range will be negative infinity, and my largest value, positive infinity. Okay, let's take a look at letter B. So for my domain, first I'm going to start by identifying if my graph is going to the left and to the right and what those smallest and largest values are. So here I'm going to the down and to the left. So that means I'm going to negative infinity as my smallest value. On the right side, I'm going up and to the right. So I'm going to positive infinity as my largest value. But now I need to consider, I actually have a spot in my graph where there is a break, and that's called a hole. When there's a hole in your graph, you can't include the x or the y value that exists at that point. So this hole is at -4, -2. So that means that my value of -4 is not included in my domain. So what does that look like as I go from the left to the right? So I'm coming from negative infinity. That's my smallest value. But as I move along in my graph, I get to the x value of -4, and that value is not included in my domain. So that means I'm going to go from negative infinity. I'm going to stop right before -4, not include it. I'm going to use this u to represent that I'm joining two parts of the range or the domain after -4, and then going forever to the right, positive infinity. So what this means, it looks definitely kind of complicated, but all is that saying is that as I go from the left to the right, I'm going from every value from negative infinity, I'm stopping right before -4, and then I'm joining up right back after -4 and going to positive infinity. Now let's consider the range. So my graph as I go down is going to negative infinity, and as I go up is going to positive infinity. But again, I have that spot in my graph where I don't include the y value of -2. So my range is going to look similar. From negative infinity, I'm going to approach -2, but not include it. Start after -2, not include it, and go to positive infinity. Okay, and now I'm going to, in this last example, look at this graph. So start with the domain. So I'm going forever to the left, negative infinity, to the right, goes to positive infinity. I have no holes in the middle here, so that means I go from negative infinity to positive infinity, just like that. Now I'm going to look at my range, my smallest value to my largest value. Well, as I look, as I'm going down, the smallest value is at that point right there, which is -5. And as I go up, it doesn't go any higher than -5. So my range, the only value that it ever exists at is -5. Okay.